Right, we're going to be talking about fault loop impedance here, and I'm just going to draw out the fault loop of a circuit here to show you what it means. Now, the key word here is loop. All right, and because as we know, current flows in a loop, and so when you have a fault, so we've got a little motor out here, and it's a single phase motor, and it's fed from a distribution board. The dB is fed from the main switchboard, and the main switchboard is fed from the transformer. Now, obviously, that's a three-phase transformer, and but we don't need to draw in all the phases because all the phases will be the same and it just get a bit confusing. So we'll just do a single phase drawing of it, and we'll draw in the loop and we'll trace it out so that for future reference, when you're working out fault loop impedance and things like that, you'll have an idea of what is actually being taken into account, because as you know, there's limits on fault loop impedance. We don't want it to be too high. That's what table 8.1 is all about. There's maximum values for different circuits and different circuit breaker sizes. So let's just start with the transformer here. And so the first thing in our loop is our phase winding. There's three on here. And of course, as you know, at a transformer, the star point, which is our transformers will all be connected in star, it's earthed. All right, so that's the first point that's earthed. And our mains, now of course, from the transformer but to the time it gets to your main switchboard, it might go through a few different sets of cables. It might go through, it might be off the transformer, you might have your street mains, and then off that you've got your aerials going to your house, and then you've got your cons mains going to the main switchboard. But that's all incorporated in that there. And then let's say you've got a main switchboard, you've got a few circuits on it, and one for your dB. Say this one, we'll draw that in to the dB there, and then from the dB we're going to go to our motor. All right, and then of course you've got your neutral. Now of course in your cons mains there's no earth, so we'll just run a neutral into our main neutral link there. And there, and then we've got a sub-main neutral. Then we've got our final sub-circuit neutral to the winding there. And of course then we've got the earth. Now of course at the main switchboard you've got your MEN link, and that's where we get our earth at the main switchboard. Okay, so that earth's in there. And now we can decide. We'll call this, we'll put an MEN in at the distribution board. All right, so we won't run an earth with it. Now if you want to check that out, what you do there, what that's all about, you can go to 5.5.3.1 and have a look there if you're wondering, and I think it's section 6, part 6 I mean. All right, so that's just for your reference. Now of course we've got to run an earth to this motor, and so there it is, the earth to there. Now of course when there's a fault, if there's a fault out here on this motor and the active comes in contact with the frame, it'll look like that, and so that's going to cause a fault. So your fault is going to flow from here down your actives to the main switchboard, and of course it's got to flow all the way back, otherwise it won't be, there'll be no current. So it's down there, down here, through the earth wire and back along the earth wire till it gets back to here. Then it goes up the MEN. Then it goes back along the neutral. Okay, back along the neutral and back into here. And there's your loop. Now, that's a loop. It's 230 volts here, of course. And 230 volts is feeding this impedance. So you can imagine the longer that circuit is, the higher the impedance, because it's got more cable, and the size of the cable determines the impedance as well. The bigger the cable, the smaller the impedance. So once you get out here, your cable might be, 2.5 mil or 4 mil or 6. So that, compared to, the cables back here, this is going to be fairly small. And so this is your fault loop, and the fault loop impedance is dependent on size of the cables and the length. But that's what it is, and we'll come back and we'll talk more about that in some later videos.